Okay, so it says you have a reaction, which is X can reversibly convert into Y. So it says at 40 Celsius, so 40 Celsius is actually equal to 313.15 Kelvin. It gives you that Kc at this temperature. Let's say it's Kc1 equals to 0.43. And at 90 Celsius, so it's about 363.15 Kelvin. The equilibrium constant, the Kc2, equals to about 0.525. And now we want to know the enthalpy. So first what we can calculate is the Gibbs free energy at two temperatures. So at T1, the Gibbs free energy delta G1 equals to RT1 minus RT1 logging Kc1. So that's about minus 8.314 times the T1, 313.15, and times logging 0.43. So this one actually equals to 2198 joule per mole. And at T2, we know the delta G2. So in this case, the delta G2 is minus RT2 logging Kc2. So that's minus 8.314 times the T2, which is 363.15 times logging 0.525. So in this case, this one is about 1945.5 joule per mole. So in this case, we know the delta G Gibbs free energy equals to the delta H minus delta T minus T times delta S. So in this case, we know two delta G at different temperatures, so we can get two formula. That is delta G1 equals to the delta H minus T1 times delta S. We assume the delta H, right, and delta S, entropy and enthalpy does not change over the temperature. And second, delta G2 equals to delta H minus T2 times delta S. So if we plug in the number, delta G1 is 2198 equals to delta H minus here the temperature T1 is 313.15 delta S, and 1945.5 equals to delta H minus the temperature here is 363.15 times delta S. So it's equation 1, this is equation 2. So if we use equation 1 minus equation 2, what we get is 2198 minus 1945.5 equals to minus 313.15 delta S plus 363.15 delta S. So let's do the calculation. So here's 2 phi 2.5 equals to about 50 delta S. So delta S here equals to actually about 5.05 joule per mole per Kelvin. So now if we plug in that into equation 1, so if we plug in delta S equals to 5.05 in equation 1, 2189 equals to delta H minus 313.15 times 5.05. So in this case, the delta H equals to about 616.6 joule per mole. So if you want kilojoule, so that's actually about 0.617 kilojoule per mole. And this is the answer.